Good morning, children. Today we will discuss about radiation from alternating current element. Let us go with the presentation. Radiation from alternating current element. So, by using the retarded potential, we can calculate the electromagnetic field which was radiated in the space by a short dipole. That means to calculate the electromagnetic field radiated in the space by a short dipole, the retarded potential is used. So, what is this short dipole? It is nothing but the alternating current element. Also, we can say oscillating current element. So, an alternating current element is considered as the basic source of the radiation. So, what is the source of radiation here? Alternating current element. So, it also used for the building block for the antenna analysis. So, already we have discussed about the retarded vector potential. So, which is most useful here to calculate the electromagnetic field of the current element. So, in general, what is the current element ideal stands for? So, ideal is nothing but an element of length dl which carrying the filamentary current I. So, this length of a thin wire is assumed to be very short so that the filamentary current can be considered as constant along the length of the element. Because of this thin wire, it is very short so that current is constant along the length of the element. So the importance uses of the approximation is observed in the case of current carrying antenna. So in such cases, antenna can be considered as made up of large number of such elements. That means if you want to have the large antennas, so we can connect these alternating elements so that we will obtain the large antenna. So which is connected by these small elements. So hence, if the electromagnetic field of such small elements is known, then the electromagnetic field of any long antenna can be easily calculated. So let us see here how to calculate the electromagnetic field due to the alternating current element. So here this is the spherical coordinate system. So here we have theta, phi and r. So this is electromagnetic field at a point P when an alternating current element ideal cos omega t which is placed at the origin. So here ideal cos omega t which is placed at the origin along the z direction. And here we can calculate the electromagnetic field at that particular point P from the distance r. So let us write the expression for vector potential A at particular point P using previous knowledge. Already we have considered this vector potential at a particular point P. So vector potential A is given by A of r is equals to mu by 4 pi integration V j bar t minus r by nu by r into dv dash. This is equation number 1. So here vector potential A is retarded in time. So here r by nu seconds which is retarded in time where nu is the velocity of the propagation. So as the current element is placed along the z axis, already we have placed the current element along the z axis positive axis. So vector potential will have only one component in positive z direction. Hence we can write Az is equals to mu by 4 pi integration V j bar t minus r by nu by r into dv dash. So from equation number 2, so here we have just replaced, here we have considered as A of r, but we have considered here positive z direction Az. So this is equation number 2. So from this equation number 2, it is clear that so Az component vector potential can be obtained by taking the integration of V of j. So here see can be obtained by the integration of the current density J over the volume. So this includes integration over the cross-section area of the element of wire and the integration along its length. But the integration of the current density J over a cross-section area yields current I. Now this current is assumed to be constant along the length dl. So the integration of J over the length dl gives the value of I dl. So thus mathematically we can write integration V J bar so t minus r by nu d v dash which is equals to ideal cos omega t minus r by nu. This is equation number 3. So by substituting the value of integration from 3 in equation number 2. So if you substitute this one in equation number 2 in the place here integration b j bar t minus r by nu dv will obtain. So Az is equals to mu by 4 by 4 pi. Here in the place of this we can replace with ideal cos omega t minus r by nu by capital R. So this is equation number 4. Now the magnetic field is given by mu h bar is equals to del cross A bar. So as we are using spherical coordinate system, so here we have used the spherical coordinate system. So to find out the curl of A, we must find the component of A with respect to r, theta and phi directions. So from this figure already we have seen, it is clear that AR equals to AZ cos theta, A theta equals to minus AZ sin theta, A phi equals to 0. So hence A is given by del cross A is equals to 1 by r sin theta dou by dou theta a phi sin theta minus dou a theta by dou phi ar plus 1 by r 1 by sin theta dou by dou phi ar minus dou by dou r into a phi into a theta plus 1 by r dou by dou r a theta minus dou by dou theta ar into a phi. So here by using, if you observe here, a phi is equals to 0. So by substituting a phi equals to 0 in this equation number 7, and also because of symmetry dou by dou phi also 0. So here a phi 0, if you substitute here a phi 0 and dou by dou phi also 0, so this first term vanishes. So here dou by dou phi 0, if you substitute 0, so this term also vanishes. So here a phi equals to 0. So these two terms get vanished. So finally we have this term. So del cross A equals to 1 by r, 1 by r, dou by dou r into a theta minus dou by dou theta, ar into dou phi. So putting the values of a theta and ar from the equation already we have a theta, by substituting a theta and a phi, we left in del cross A equals to 1 by r dou by dou r minus az sin theta. Here a theta is nothing but minus az sin theta minus dou by dou theta ar and means az cos theta into a phi. So substituting value of az, already we have az value here, az equation number 4 we have. So by replacing az with this equation, we will obtain. So substituting az here in this equation, we will obtain del cross A bar is equals to mu by r dou by dou r minus r sin theta ideal cos omega t minus r by v by 4 pi r minus dou by dou theta cos theta ideal cos omega t minus r by nu by 4 pi r into a phi. So here by solving this, we will obtain this equation. So mu ideal by 4 pi r. So by bringing this constants here, we will obtain, and with respect to dou by dou r, we will obtain this equation. So del cross A is equals to mu ideal sin theta by 4 pi r minus omega sin omega t minus r by nu plus cos omega t minus r by nu r into a phi. That means here we have taken common as sin theta. So del cross A is equals to mu ideal sin theta by 4 pi minus omega sin omega t minus r by nu by r nu plus cos omega t minus r by nu by r square into a phi. By sending r inside, we will obtain this one. Question number 9. So hence the magnetic field H bar is given as H bar equals to 1 by mu del cross A. So putting the value of del cross A from equation number here from 9. So this is the del cross A. By substituting, by replacing here in the place of del cross A, we will obtain. So I by substituting here, H is equals to 1 by mu del cross A means here this one. So by cancellation here 1 by mu and in numerator mu get cancelled, so that finally we'll obtain this one. So equation 10 indicates the magnetic field H exists only in phi directions. So if you observe here, this one here a phi, this is in phi direction. So H phi is equals to ideal sin theta by 4 pi minus omega sin omega t minus r by nu by r nu plus cos omega t minus r by nu by r square. So this quotient we have taken here because H exists only in the phi direction. Let t minus r by nu equals to t dash. Substituting value of equation 11 we get. So by replacing this t minus r by nu, this one with t dash in equation number 11, we will obtain H phi is equals to ideal sin theta by 4 pi minus omega sin omega. So this is t dash by r nu plus cos omega t dash by r square. So after calculating the magnetic field, now let us calculate the electric field given by del cross H bar equals to epsilon dou E bar by dou T. So dou E bar is equals to 1 by epsilon. So by taking cross multiplication, we will obtain 1 by epsilon del cross H bar into dt. That means separating the variables. So integrating with respect to corresponding variables, we will obtain E bar is equals to 1 by epsilon del cross h into dt. That means the derivative and integration cancelled here in left hand side. So we will obtain here. So let us calculate each term of del cross h separately. So from the definition of curl of a vector, the component of in AR direction is given as del cross h bar in direction r, which is equals to 1 by r sine theta, dou h phi sine theta by dou theta minus dou h theta by dou phi. So this is the, according to the definition of curl of vector, component in AR is given as this one. But dou by dou phi is equals to 0 already we have. So del cross h r, which is equal with respect to r, which is in r direction, which is equals to 1 by r sine theta, dou by dou theta, h phi sine phi. So because here dou by dou phi is equals to 0. So this term becomes vanishes. So substituting value of h phi from equation number 12. So here uh, h phi already we have equation number 12. So by replacing h phi here with 12, we will obtain this equation number, this one. So del cross h in r direction equals to 1 by r sin theta dou by dou theta ideal sin theta by 4 pi minus omega sin omega t dash by r nu plus cos omega t dash by r square into sin theta. So del cross h in r direction is equals to 1 by r sin theta. So let us take common as ideal 4 pi, and by rewriting this we will obtain here this one ideal by 4 pi. So here minus omega sin t dash by r nu plus cos omega t dash by r square. So dou by dou theta into sin square theta. So del cross h in r direction equals to ideal by r sin theta 4 pi minus omega sin omega t dash by r nu plus cos omega t dash by r square into 2 sin theta. So sin square theta with respect to derivation of theta, we will obtain 2 sin theta cos theta. So del cross h bar r in r direction, which is equals to 2i dl cos theta by 4 pi minus omega sin omega t dash by rv square plus cos omega t dash by r cube. So by taking r inside, we'll obtain this one. So sin theta and here sin theta get cancelled. So that this is equation number 14. So let us calculate the component in a theta direction. Already we have checked in r direction. Now a theta direction, a in theta direction. So del cross h bar in theta direction 1 by r, 1 by sin theta dou h r by dou phi minus dou by dou r into h phi. Again dou by dou phi 0. So dou by dou phi here 0. That means this term vanishes. So del cross h over theta is equals to 1 by r dou by dou r into h phi. So again substituting h phi in equation number 11 already we have. So by replacing h phi we will obtain this one. So by solving this equation, finally we will obtain with respect to this term. So by solving this one, we will obtain del cross h with respect over theta is equals to minus ideal sin theta by 4 pi omega square cos omega t minus r by nu by nu square r plus omega sin omega t minus r by nu by nu r square minus cos omega t minus r by nu by r cube, which is equation number 15. So finally component of del cross h bar in a phi direction is 0. So from equation number 13, component of E in a direction AR is given by ER equals to 1 by epsilon integration del cross H R into d theta. So by substituting the del cross H with respect to R from equation number 14, we will obtain ER equals to, already we have this equation number 14, this one del cross H in R direction. So by replacing here we will obtain, so here integration this one 1 by epsilon integration 2 I dl cos theta by 4 pi minus omega sin omega t dash means t minus r by nu by nu r square plus cos omega. Again t dash means we are replacing with t minus r by nu by r cube into dt. So 2i dl cos theta by 4 pi epsilon omega. So by taking this integration, we will obtain omega sin omega here minus cos omega. So minus into minus plus t minus r by nu by nu r square into 1 by again omega. So sin omega t minus r by nu by r cube into 1 by omega. So by taking integration, we will obtain this one. and to ideal cos theta by 4 pi epsilon cos omega t minus r by nu by nu r square into, and here omega get cancelled here, plus sin omega t minus r by nu by omega r cube. So er equals to 2I dl cos theta by 4 pi epsilon cos omega t dash by, so t minus r by nu is nothing but again t dash by v nu r square plus sin omega t dash by omega r cube. So similarly from equation number 13, component of E in a theta direction is given by E naught E theta equals to 1 by epsilon integration del cross H bar into over theta into dt. So again replacing the del cross H theta, we will obtain this one. So E theta equals to 1 by epsilon, and this is del cross H theta. So by simplifying this equation, finally we will obtain E theta equals to ideal sin theta by 4 pi epsilon minus omega sin omega dash by nu square r plus cos omega t dash by nu r square plus sin omega t dash by omega r cube. So this is finally we will obtain this output. So by simplifying this one, we will obtain E theta value. Thank you, children.